Assalamualaikum and very good morning to all of you. Welcome to this video of tutorial 2.6, which will discuss about the main reinforcement design of rectangular beam at the mid span, where this case is considering doubly reinforced. Okay, here is the example. In the module, you can refer to page number 54 to page number 56. Okay, the question is, design the main reinforcement for the rectangular beam. Okay, this is the keyword rectangular beam shown in figure 2.6 below, which is located at the midspan. So if at the midspan, the tension reinforcement is located at the bottom or at the top part of the section. Any answer? Yes, it will located at the bottom part because the tension will occur at the bottom, so the tension reinforcement will be placed at the bottom, and compression reinforcement will be placed at the top part of the beam. Okay, so this is the design data. Now let's proceed to the solution. Okay, first of all, you have to determine the value of D and the D prime. Okay, so now let's start with D. Our H is equal to 5. Yes, 550. The C nominal 30. Diameter of link 8, and then diameter of tension reinforcement 20/2. So our D 502. Thank you. Okay, how about our D prime? C nominal is equal to 30 plus diameter of link plus compression reinforcement 16/2. So the answer is 46 millimeter. Okay, so this is 46 millimeter. So we have to determine the value of K. So the bending moment given the design moment from the analysis is 250. You have to multiply by 10 to the power of 6, okay, for unit conversions, and divide by the FCK. Our FCK is 35, okay, times 225 times the D of 502 square. Okay, what is the value of K? 0. Okay, 0.176. So you compare with the K balance. Okay, this is greater than 0.167. So the reinforcement is doubly or singly. So this is we consider as doubly reinforced. Okay, where we have to consider the compression reinforcement at the top part of the section. So okay, we have to calculate the value of Z. So in this case, the K is equal to K balance, which is equal to 0.167, and the Z is equal to 0.82D, which is also known as the Z balance. So the area of total area of steel required, okay, for compression reinforcement, K minus K balance, so 0.176 minus 0.167, so times the FCK of 25, BW times D is 25 square, divide by 0.87 times 500 and 502 minus 56. So can you give me the answer of S prime required? Okay, good. 64.3 mm square. So by referring to the table of steel reinforcement, which combination you want to propose? 2H16. Yes, because we determine this is a area of compression reinforcement required, and our Diameter of compression reinforcement given is 16 mm. So we refer to the row of 16 mm only. Okay. And we can ignore other row. Okay, so what is the number? 402, yes. So you want to propose 2H, okay, 2H16. So the provided is 402 mm square greater than AS prime required. Okay, why you not use 1H16? 1H16 is 201, also greater than required. Any answer? Not balance, okay, because it's impractical on site. Okay, later, okay, they say this is your section. Okay, and this is your tension reinforcement, and this one is your link. Okay, so if you provide only one, you provide here, this is impractical on site. So minimum you provide two. Okay, this is impractical for the workers to install this kind of reinforcement. So you provide minimum two. Okay. So you can provide two. Okay. Okay. Now, make sure you put you draw or you sketch at the exact locations. Okay, because in this case the compression reinforcement is located at the top part of the section, so it's at the top. Okay. Okay. Next, the tension reinforcement, as I mentioned before, you have to determine the D prime over D, which is equal to 46 divided by 402. Any answer? 0.091, okay, less than 0.167. So you can use previous equations for AS prime required. Now we can proceed to AS required, which is K valence, okay, 0.167 multiplied by FCK, and then 225 of BW. Z balance is equal to 0.82 D. Our D is 502. Okay, but please, this one, you plus. You have to plus with the AS prime required. Okay, so this one you plus 64.3. Okay, 64.3. Please don't, while you're using your calculator, please don't miss this part. Okay, 64.3. Okay, so any answer? Okay, 113 at 6.3 mm square. So any combination of steel you want to propose? From this table? Okay, you use 20, okay, for our, okay, so you refer only for 20. I mean the row of steel bar size 20. Okay, only refer to this row. Okay, so any idea? Okay, good. 5, sorry. Okay, so 5 page 20, so equal to 1571. So you provide 5 page 20. Oh, sorry, this is required. Okay, sorry. Okay, wrong, wrong space to write. It's okay. 1386 kan? 0.3 mm square. So 5H20. So 1571 mm square. Okay. Next, as usual, you have to check the S minimum and S maximum. So by refer to table 3.1, what is the value of what is the value of FCTM for concrete class C25/30? 2.6, okay, 2.6. So you can settle this one. Okay, 6 must be greater than this one. Okay, 225. Okay, any answer? For S minimum, any answer from this one? 152. Okay, 152. 1.7, so make it 153 mm square. And then another one. One. Okay. Okay, 147 mm square. So you use the larger one, 153 mm square. This one is lesser than AS provided, means okay. And then how about the AS maximum? Any answer? 4950 mm square greater than AS provided. Okay. So your AS provided must be in between of, okay, here I write down. Okay, so your AS provided, make sure AS provided is in between of AS minimum and AS maximum. Okay, and then you go for the detailing of the cross sections. Okay, you have to sketch the detail. Okay, let's say this one is your section. So you just sketch the value of your BW225 and then sketch the value of your H of 550 and then your, okay, the standard of your compression reinforcement at the top is 2H16 and then at the bottom is 5H20. You can put in one row, but maybe it's too, I mean the spacing will be too narrow. Okay, you can put like this one, 2, 3, 4, 5, but you have to check the spacing of the bar. Okay, if the spacing is too narrow, we will learn this one later in chapter 4. But okay, so if this spacing is too narrow, the concrete, I mean the aggregate from the concrete cannot pass through. So we have to rearrange our steel position. Okay, three number of bars at the bottom and 2 numbers at the top. Okay, slightly like this one. Okay, so this one is 2H20 plus 3H20. And also, okay, complete your link. Okay, this is your link as a loop. Okay. Okay, this is how to sketch the detailing of your cross sections. Okay, congratulations, you just finished to do the tutorial 2.6. So you can enjoy the set of exercises from the module, page 57 to 58. However, I have one question for you. How to avoid doubly reinforcement in design? In your opinion? In your opinion? How to avoid doubly reinforcement in design? Any answer? Okay, it depends on the value of K. Okay, either is lesser than 0.167 or is greater than 0.167. Okay, it depends on the value of K. So how to make sure how to avoid doubly reinforced. Maybe you just want to calculate for singly reinforced, right? It's okay. I leave it to you to think the answer and do your research. I give you clue. It depends on the K. So how to reduce or increase the K? Okay. So thank you very much for watching this video. I hope you enjoy learning something new from me and see you in next video. Assalamualaikum. Bye bye.